Thanks, Greg. Hi, my name is Mike Percy. I'm a software engineer at Cloudera and a PMC member on Apache Kudu. And today I'm here to talk to you about using Kudu and Spark together. So just by a quick show of hands, who here knows what Kudu is or feels like they understand what it does? Okay, that's like half the room, I think. What I was planning for today was essentially do sort of an introduction to Kudu for people who don't know what it is, and then show a demo of using Kudu with Spark, and then talk about kind of how Kudu integrates with Spark, how you can use Kudu with Spark, and and if we have time, talk a little bit about roadmap. So a little bit about myself, really quick. I've been at Cloudera for 4.5 years, been working on Kudu 3 years, which is about 2 years longer than it's been sort of a public thing. It's now a top-level project at the Apache Software Foundation. Prior to working on Kudu, I also worked on Flume for some time at Cloudera, and then prior to Cloudera, I was at Yahoo for a while working on big data infrastructure and stuff. So, quick overview. So, the reason that we decided to build Kudu is because traditionally, and by traditionally I mean, sort of the latest big data technology, we've had HDFS and HBase, sort of two prototypes of storage that are useful in sort of the Spark and the greater Hadoop ecosystem. HDFS, as I'm sure you're aware, is really good at being an append-only data store. It's really fast to write to, it's really fast to read from, especially sequential scans, and if you combine it with Parquet, you get great analytic performance. Does anybody here use Parquet? Okay, a lot of people. So on the other end of the spectrum, you have something like HBase or Cassandra, these NoSQL data stores that are really good at random access. Inserts, updates, and deletes, they make your data storage mutable. But they have some drawbacks. Some of the drawbacks are related to how they lay out data on disk. So the way they lay out data on disk is essentially sort of an encoded row-oriented format, which means that if you want to read a single column, then you have to do a lot of decoding and do a lot of seeking if the data is not in RAM. So the problem is that, what if a lot of analytical workloads, what you want is a lot of data coming in really fast, you want it to be visible immediately like you're used to with traditional relational databases, but you also want really fast scan and analytical performance. And before Kudu, that just wasn't possible, or at least not within the ecosystem. So Kudu fills that gap. The way it does that is it combines some of the concepts and the technologies used in Parquet with some of the concepts and architectural pieces used in HBase. And it effectively puts these together to create a native pure column store that gives you immediate access and visibility to your data while also making it really fast to do analytics and scans. So what is it? Well, as I just said, it's a structured store, and what that means is you have tables, you have a strict schema, and so you define integers and timestamps and strings as part of your create table statement. Right now, Kudu doesn't support blobs. We may add that optimization later in the future. But the beauty of it is you get individual random access to huge tables, hundreds of billions of rows. So it also scales out like the rest of the components in the Hadoop ecosystem. We've tested it up to about 275 nodes with good results. It's designed architecturally to scale to thousands of nodes. We're working on getting there. In terms of the per node performance, it's also super fast, and in aggregate, the performance is great. These are, just really quick, these are the data types, sort of the standard ones, bool, int, float, double timestamp, decimal is on the roadmap. It's also got an online fast alter table operation. So for those of you used to some other systems that don't provide that. It doesn't interrupt your data processing to alter the table and, for example, add a column. The primary ways of accessing Kudu are sort of two-pronged. One, there are many NoSQL APIs, or well, several, Java, Python, and C++. And I'll show a quick example of that. And then SQL integrations via Spark and Impala. And those systems actually use the NoSQL APIs to achieve this. So again, it's just storage. In native NoSQL, the SQL is translated from some other system into Kudu's APIs. So here's an example of one of Kudu's NoSQL APIs. This is the write API for Java. And essentially, you have some insert, you create an insert object, you add a bunch of fields to this object, then you apply it to your session and you flush. And this flushes the data into Kudu, and then it's immediately visible. This is the read side. The read side is, this is exactly what Spark uses when translating from like Spark SQL into Kudu. It essentially creates a scanner object, and then it may project some columns. If you say select ID, it's going to project ID, and then it's going to use an iterator type interface to pull that data down on a per node basis, typically, so that you get efficient parallelized scans. And these are some of the other types of predicates that you can do. You can just look this up, but anyway, this is an example. All of these predicates are pushed down into Kudu so that Spark doesn't have to do extra work. Tables are just a couple more details about Kudu before I get into the examples. So Kudu is, while tables are represented in Kudu as sort of a traditional table, Kudu is partitioned or sharded into tablets. So it's, you could also call it horizontally partitioned. So this is similar to something like HBase. Some of the differences are that you can use range partitioning, hash partitioning, or both. So you can range partition on some column, hash partition on some other column, something like that, to sort of get the partition layout that you want to get good insert performance and also get good scan performance. This is sort of an example of it's like a partial create table statement. It's not really a full valid SQL statement, but essentially you could do something like, well, this is Impala syntax, but create table with some schema, primary key, blah, 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 distributed by this. This is how you get your partitioning and your distribution. And the fault tolerance is based on Raft consensus. So typically each tablet has a certain number of replicas, maybe 3. And if one dies, then Raft will kick in, elect a new leader, and you'll be back up and running in 5 seconds or something like that. Raft is a strict quorum algorithm that basically gives us strict consistency, for those of you that are wondering. The master is just a special type of process that hosts its own special type of tablet. Internally, it uses the same replication that the tablet servers use, but essentially acts as a catalog and stores your metadata. And then acts sort of like DNS. Clients hit the master to get location information about the rest of the cluster, and then they cache it. So Kudu has a bunch of integrations: Spark, Impala, MapReduce, Flume, and Drill right now. There are more up and coming, but it's already well tested with these systems. Except for Drill. Drill's a little bit sort of early. Okay, so what does Kudu bring to Spark? So Kudu brings Parquet-like scan performance, but as I mentioned, no data visibility problem, no data visibility latencies. So push-down predicates, as I mentioned, primary key indexing. So if you use Parquet, but you want to look up a single row, you're going to have to do a bunch of scanning. In Kudu, it's very fast. Maybe if it's on disk, if it's on an SSD, maybe it's like a millisecond to sort of access that SSD and look it up. If it's cached in RAM, then it's super fast. So this is an example. This is what the Spark data source, this is how you can use Spark with Kudu. So you start up the Spark shell, specify this package that's up on Maven, and then you essentially import the package and then create a data frame specifying the master location, and the table name. You can use all kinds of Spark API stuff on that data frame. And then if you want to use Spark SQL, then you essentially just create a temporary table from that data frame, and then you can sort of treat it like a regular Spark table. So I'm going to give a quick demo of this. Let me know. OK, so I did a little bit beforehand, because when you start up the Spark shell, there's a little bit of a delay if you don't have the Hive meta store and stuff like that. You can see I forgot to import before I loaded the data frame. But anyway, I just did this just a minute ago. So essentially, what I did is I just did the import right here. By the way, can people see the text? Yes? OK, perfect. And then, so this is the data frame. This is what I just showed. I have Kudu running on my local host. I'm running Ubuntu. And then I have a table that I created called Twitter. So then this is the table that I have now. So I'm going to do a couple of things. I'm just going to describe the table. Oh, OK. What I didn't do is I didn't create the temporary table. So I have to register the temporary table using data frame. OK, now I can do what I just did. OK, I get it. Twitter. OK, so now I'm going to do a couple of little things. This is just a really basic demo, kind of, to show what you can do. Count star. You can do, I don't know, like let's select the top users that have the most followers, something like that. So like your standard stuff. Basically anything you want to do in SQL, you can do it. So the beauty of this is that you can use all the power of Spark SQL with Kudu. For example, you can push down to Kudu for data that isn't going to fit in RAM, and then have Kudu sort of like number crunch it. You can use Kudu for your permanent data store, and then you can use views on Spark SQL to hold sort of these temporary tables. I know some people doing that with really good results. So they're a really nice combination because Kudu's going to give you all the columnar performance that you would expect, and also Spark SQL also has good columnar performance internally. So that's it. That's the demo. But I'm going to show some more of the APIs. So if you want to write from Spark, then you basically create a Kudu context. This is a Kudu object. And then you use that you can create the table, you can insert rows, you can delete rows, and you can take this data frame and basically insert rows using that data frame, and all the kind of stuff that you would expect. But the beauty of it is you can update and upsert and stuff like that, which is something that's not really possible to do or efficient to do using something like HDFS if you want to persist this data. So some of the optimizations that I was talking about, you can see that they're being used. So if you select average value from metrics, this is just an example, and you do an explain, then you're going to get this back from Tungsten. And it's going to say, OK, yes, I'm querying this single partition, and I push down this filter to Kudu. This equals to some host. So that's an example of one of the push down filters, the equal to. It does a bunch of stuff. It not only pushes this down to the individual server layer, but also in a wider perspective, it also prunes the partition. So if it can tell which partition it's supposed to go to based on this predicate, then it won't spam the whole cluster with all of the information, with all of these queries, and only get back from one of them. It knows to only contact just the one. And that's based on the metadata from the master if a host is partitioned. So I want to talk about some use cases for what Kudu is good for. I think a lot of folks, if you're using Parquet, you probably have an idea of your own use case. these are some more sort of general ideas of what people are doing. So Kudu's really good for stuff that requires simultaneous sort of random access, low latency updates, and really high throughput scans. So time series is a good example, fraud detection, network monitoring, stuff like that. Also, stuff that you might typically do with an operational data warehouse. Kudu doesn't currently have multi-row transactions or atomic loading. So that's something to keep in mind. But at the same time, a lot of analytical use cases, you can get around those things. You can create and drop partitions on the fly as well. Also, Kudu doesn't currently implement secondary indexes, so you need to do clever schema stuff that you already do with probably HBase or Cassandra to get the indexes that you want. So I want to talk about one particular use case, since I think it's interesting. Xiaomi, has anybody heard of Xiaomi here? Okay, they're a huge cell phone maker in China. And essentially what they are using Kudu for, they've had Kudu in production for about, I think it's been 9 months. And essentially what they've been doing is gathering RPC tracing events, and also information from their app on the phone, information from their cell towers, and basically their different services and stuff like that. And then what they want is to provide their customer support with the ability to look up problems. If they get calls, they want automatic alerts to come to their ops people, and they want dashboards and reporting. And they want it all to come from the same system. And they also have a very high write throughput. These are actually old numbers. So their previous pipeline looked like this. Essentially, they were using, actually, the data sources is many different systems, but imagine that's imagine that's more than one box. And they were using scribe to sequence file, and also using HBase for data that they wanted to land immediately. And then they had a bunch of different jobs that would sort of merge stuff from HBase and from their sequence files together. They would store it in HDFS on Parquet, and then they would use Impala to query Parquet, and then they would basically feed either like reports or cached data into MySQL or stuff like that to get the results that they wanted, to sort of pull all this together. They had one big problem that they had, though, is that the data ordering thing. So essentially, if you have, like, cell phones are very offline type of systems. So if you are out of your service area, you come back in, like 3 days later, it's going to report back for that day. So what this means is if they wanted a high probability of getting all the data for 1 day, they had to query like 3 days of data. The other problem is that their ETL pipeline took a long time. So these are some problems that they had. With Kudu, they also put in Storm. You could also use Spark streaming, I think, just as well for this use case instead of Storm. And so they're using Scribe to Kafka to do to feed their ETL pipeline. And then for data, for systems that can tolerate back pressure from Kudu, maybe there's a network problem, maybe Kudu is down or something like that, then if for systems that can tolerate those kinds of things, then they can go direct to Kudu, 0 latency. Otherwise, they have this 10-second latency kind of a thing. And then they're using Impala to serve their dashboards and stuff like that. And they also have other systems that directly contact Kudu to get up to the moment information. So, effectively, with Kudu in the picture, there's only one system to operate. You don't need cron jobs or background processes because Kudu schedules these threads and manages all of this partition creation by itself. The data is always sorted the way it's supposed to be. So basically, instead of building all of this stuff yourself, Kudu does it for you. So in many ways, it really simplifies Lambda architecture. In many cases that need a Lambda architecture can use Kudu instead. I think I'm running out of time, so I'm going to skip this slide. I wasn't exactly sure how long I was going to spend on that last one. I'm also going to skip columnar storage because I assume most people here know what it is. So let me jump to the roadmap. So I know what my team is working on. Obviously, like in the open source, there's no official roadmaps or guarantees. Right now, Kudu doesn't have Kerberos support. So that's on the roadmap right now. People are working on it. People are adding Kerberos GSS API and stuff like that. Sort of initially, I think what we're going to do is basically you get like a whitelist of like root users, you know, and then eventually we'll add more fine-grained support. That looks like what the roadmap is right now for security. Ultimately, we'll get down to finer-grained authorization. Actually, Kudu's been quite stable. We do a lot of fault injection and stress testing and stuff like that. Can you guys still hear me? Okay, I didn't mess up the mic. And so the recovery tools, we have a bunch of recovery tools that we're sort of creating for if you hit some disaster scenarios or like some corruption or something like that. If you lose half your data center permanently, you know, then we're creating stuff to sort of fix that. Some of it's there, some of we're working on it. Also, all kinds of performance improvements and scalability improvements, and different types of pushdowns and stuff like that. Also, stats for Spark. And finally, client improvements. So, for example, we want full feature parity. The Python, from what I'm told, Python client works with Spark. But we want to sort of continue improving the Python client. In terms of performance, so over the last about a year, we've made really large improvements to the compaction. We also have made a lot of improvements to filters and stuff like that. We've also been improving startup time. So anyway, we've been making a lot of work over the last year since we first announced Kudu. And on a YCSB workload, essentially we've really improved our throughput since we first initially released Kudu. So a quick benchmark just to compare. So this was about a year ago, so it's going to be actually better, but this was a workload that was essentially would fit in memory, but Kudu is actually faster than Parquet. And that was because Kudu supports more pushdown filters in a more efficient way than Parquet does. So anyway, so obviously Parquet can catch up, but for in-memory data, Kudu's on average faster. When it's not in memory, Kudu's still slower. It might be 2 times slower than Parquet. And that's because Parquet has slightly more efficient IOs. This is a log scale graph. I won't go through everything, but essentially for TBCH, for folks familiar with like Apache Phoenix, which is an OLTP system based on HBase, for analytical workloads, Kudu really is much, much faster. However, for single row lookups, Kudu's still slower than something like Phoenix and HBase. And that has to do with some sort of disk layout trade-offs and stuff like that. So this is the current Kudu community, and by that I mean people who let us put their logo on the slide. It's also, well, it's not just that though. It's people who are contributing to Kudu, people who have integrated with Kudu. There are a bunch of people who are currently using Kudu in production. So it's growing pretty quickly. So to get started, on the web, well, it's kudu.apache.org, sort of the obvious choice for an Apache project. We also have a user mailing list. There's also a Slack channel. So you basically click on the community link on the website, you can get an auto invite, and all the developers and lots of users hang out in there. So it's a nice way to sort of say hi and ask questions. There's also a quick start VM. And for people who use Cloudera Manager on their cluster, there's also a CSD and parcels to make installation easier. There are also RPMs and stuff. To get started as a developer, if you want to contribute or just check out the code, it's all on GitHub. I just put the GitHub link because the ASF link is really long. All of our code reviews are on Gerrit. It's Cloudera hosted, but it's like everything goes through there. It's totally public. and invisible. We also have a developer mailing list, and of course, we're on the Apache Jira. And we have we've added one of our PMC members is from Xiaomi, so it's it's an open community. And that's it. That's all I had. Does anybody have any questions?
All right, great. So if we have questions, we have 2 mics here. And remember, the mics actually are, they're not very good at picking up if you're far away from them, so please get close. And if there's anybody in front here who has questions, I can come run up to get you. Right there.
Hey.
Pardon me, sir.
Were there? Oh, yeah.
Hi, thanks for the talk. It wasn't clear to me, does Kudu actually use HDFS, or does it just store on the local file system?
It's the local file system. Yeah, it was like a bullet point on the slide, but I rushed through that one. So, and the reason that Kudu doesn't use HDFS is that it does its own replication and fault tolerance. And because HDFS has its own sort of system, then it's not really architecturally easy to do that, to use distributed storage and also Raft consensus for fast failover. And Raft consensus, we have a mean time to recovery of about 5 seconds, which includes fault detection and then leader election. So fault detection, it's tunable. But fault detection can take, I don't know, 1.5 seconds or a couple of seconds. Usually it's tuned to 1.5 seconds, and then leader election can take a couple of seconds, basically to complete, to get the votes, and then decide that a leader has won, and then have it come up and actually be available. But so basically, something that I quickly went over is if there are 3, say there are 3 replicas per tablet. If the leader goes down, then this process has to happen, and there's some kind of a delay, like a 5-second recovery time or something. If one of the followers goes down, but you still have, say 1 goes down, but you still have 2, then you won't notice it, actually. And the master will detect after, by default, 5 minutes that one of those followers didn't come back, and it will re-replicate and auto-heal the cluster, that tablet.
Hi, I've got a question about the consistency that you're using. Is the consistency tunable at all? As in, can you choose to just have one replica right and not care about when it gets replicated or anything like that?
Sort of. So the consistency, the read consistency is tunable. The write consistency is not. So if you want to read from a follower, then you can get, then you don't get any guarantees. You can get arbitrarily delayed data. If we're working on adding sort of the fine-tuning the consistency so that you can always get exactly once. Right now it's like there are a couple anomalous sort of edge cases that we've identified and we're working on. We knew they were there, but we didn't prioritize them all. And so anyway, so that's the that's sort of long story. Long story short, we're working on making more tunability. Right now, you sort of have like always like super consistent or arbitrarily inconsistent options.
Thank you.
For reads.
All right, so we are running just up against the limit of our time for this talk, so let's give one more round of applause. Thank you very much.
Thanks.